Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench is the, what I promised is a ROTEL RA-1412. And decided to start this today. It's minus 25 outside and snowing. And it's a miserable day. I don't want to be out there. I want to be inside doing something in the warmth. So let's start on this one. This one is the second of the two ROTELs that my friend brought me, my client. And I already did the receiver, and you saw that. It was a few weeks ago. So now we're going to get into this amplifier. Same kind of power, same kind of features, without the tuner, of course. And this one's built to next level compared to the previous receiver I just did. This one's a little higher tier. It's got more engineering, more goodness in it, and same power, like I said, but you know, there's a lot here. This is quite a beast of an amplifier. It's fairly big, although it's not as big as the receiver I just did. It has all your inputs on this one side. We've got two phono inputs, a tuner, auxiliary, two auxiliaries, two tape loops, a preamp out, main amp in, and then we can split or unite those two with a switch, and we can add our own amplifiers if we want. Or you can break out the signal from here and add another amplifier and continue using the internal one. DIN connectors for both tape loops. We've got selection for phono. We have a DIN input for a phono, which is kind of uncommon. I don't know how many, especially in North America, that's really unheard of. Maybe in Europe they had more of this, DIN connectors for the phono, but not here. We got a selection for input impedance, 25K, 50K, 100K, so we can select our input impedance for the phono stage, and we can also select input sensitivity 2, 4, and 8 millivolts. So there's a lot of flexibility here with your phono stage. On the other side we have all our outputs, and we have 3 sets of speaker outputs. Okay, so, and on the back we really have nothing but on the back, you can't really see it, it's all dark here. Let me see if I can get some light on this. We have our input line, we have a fuse, main power fuse, and 4 courtesy outlets, all switched. And then we have our heat sinks for both amplifiers. Up front we got a nice couple large power meters, an overload light. We have our selection for our 3 speakers. Bass and treble control with cutout and hinges for 200, 400 hertz or 2.5, 5 kilohertz. A low filter of 15 and 30 hertz. High filter of 8 and 12 kilohertz. Our mode switch is reverse, stereo, left, right, left plus right, mono. Loudness switch, 2 tiers for that, and a 2-tier muting switch, minus 10 and minus 20 dB. This is our tape monitor switch. Two tape monitors, and we can do dubbing from one to the other. And then we have push button selector for our inputs, and a microphone mix potentiometer. We can mix in a microphone input. Very versatile and very nicely laid out. It's got all the controls you really want. So I had the pleasure of connecting this up to my analyzer and doing distortion tests, and the power output is good, distortion is good, frequency response is good. I did notice there was one problem with one channel bleeding through to the other on doing some of my power tests. I don't know what's going on there, if that's an issue. We're going to look into that and see. But this by design should be 2 separate mono amplifiers, and the only place where there would be interconnection would be in the preamplifier stages. So I'm going to look into that. Screws are out, lid's coming off. It's a nice heavy steel lid. It's clean on the inside. We open it up, we can see we have 2 separate power supplies for the power amplifiers back here. So all of this at the back is a stall power amplifier, and I think the protection circuits lay below the deck. And down here we have our tone control board, preamplifier circuits, and a stepped attenuator for our volume control and balance pot. So hopefully there's no problems with this. All along this side we have our input board, inputs, all our inputs, and we have our input function switching is all in this switch, all in this. And we probably also have our phono stage somewhere in the bottom here hidden. Can't see it from above. On this side we have our power switch. You can see there's something wrong here. The switch should not be moving like that. We have a problem with the switch mounting screws are missing or something. That's bad, because every time you manipulate the switch you're flexing something, and eventually things will crack and break. You can't leave it like that, so we'll have to address that. And then we have our outputs here on this card, and I don't know where the relays are. I don't see any relays here, but let's flip it over and have a look. Here's the underside shot, and we can see up here we have our phono stage laid out. It's all enclosed and shielded, so I expect this is a very quiet amplifier. Here we got power supplies. This was loose. I wonder if somebody had this apart. It seems like things are missing, or screws are missing. We got power supply for each channel, and I think this supplies regulated voltages for the early stages of the power amplifier, as well as it's got some beefy diodes here for doing the rectification for these two caps. These two caps will be for this amplifier, and then these two caps will be down for this amplifier. And we have rectification here. So that's all good. Now I did test these caps, and they are down in value. They're supposed to be 22,000, sorry. 63 volts, yeah. And they are down in value to about 17 or 15,000. So just like the other receiver, I'm going to replace these four. I already got them. I ordered them before with the receivers, so they're here. Now I can just pop them in. Great big monster tone board here with all our switching and tone controls. These are not actually potentiometers, but they are, the bass and treble controls are switched attenuators. So here's a treble control, and these are all switched. And with each position of the switch you'll have a resistor capacitor network. So these will need to be taken apart and cleaned, because if there's one spot on the rotation where it doesn't connect, you're going to get a dropout. Switches, same thing. I'll take those out, clean those. And then other than that, I'm going to do the usual recap. What is this? What is going on here? Is that factory? Okay, so we got purple and green coming out this purple and green out of here, and they're cutting it off and not using it. So I think these are just extra wires that they're not using on this transformer, and they just blocked them off. Okay, so I'll get started, remove the knobs and faceplate, get everything off, and then we can start servicing. I'll probably start on this tone board, start servicing the switches and replacing the caps. So it's going to be a bit of a job here doing this one. Okay, right off the bat I got a huge problem here. I can't get this set screw off of this knob, and I'm scared I'm going to strip it. It's a 2mm hex socket on that set screw. I'm just going to dribble down some oil. I can see rust in the hole, like it's been, like, I don't know if it's been wet. Just going to dribble a drop of oil down that hole and let it set for a few hours, and then I'll come back and try it again. And hopefully this is not a problem. The only other thing I could do is drill out that set screw, and that would be, geez, I don't know if I want to do that. Let's try and avoid that. Okay, somebody's definitely been in here before. This is, these masks have been all messed up, put together incorrectly. I had a problem with the balance pot knob. There is a small piece missing, broken off. This piece of black plastic is missing there. You can see it's broken away. Thankfully, I think the knob is okay. I think somebody either pushed on it or tried pulling on it or something. I don't know. And screws are missing from the switch block. Well, you can see that. These two screws are missing. So whoever was in here doing service, let's see, is yeah, they should rethink things. I'm just getting things prepped here. I'm just removing the power amps. Pretty simple. 4 screws in the back, 2 screws in the bottom, and then the amplifier is released. Just got to desolder these pins. That's easy. And then a couple screws to release the back, and we can just pull these out separate, service these separately. I'm probably going to put the screws back in just to hold the case together so it's not falling apart. I still want to remove this side. This side has the speaker protect circuits and the speaker relays underneath. I can see it from below with all of the switching here. So I'm going to get that out. And I'm probably going to end up removing these boards. This one and this one. Probably not this one. But I'll remove the ones on the sides, make it easier for servicing. It's really not hard to remove these pins. You just desolder the pin, pull them out, clean the pad off so that the hole's open. When you put it back together, just solder it together. It's simple and fast. This needs a lot of cleaning in here. Somebody tried cleaning it, but you just can't get down inside with all this stuff. So you got to start removing things to expose all the dirt and filth that's underneath here. I don't know if you can see it. It's yeah, so it's going to get all cleaned on the inside and out. And I'm just going to continue disassembly for today. Alright, so I'm pretty much done with this board. This is the Phono stage input board, input switching, and the microphone. The microphone amplifier is right here. So I replaced all the caps, and for the most part the electrolytics were okay, except for a couple of, let's see here, a couple of these Elnas were out of tolerance. And I replaced all the tantalums, and these are low noise, or low, yeah, I think they're just low noise caps. These test out pretty good with the epoxy bottoms. Sometimes I find these are bad, sometimes I find them they're perfect. So I just replace them anyways because, you know, why not? So everything here is done. Now I did a lot of work on this board. I went through and tested contact resistance on all these switches. These 5 switches here are the input selectors. So you got tuner, auxiliary, phono 1, 2. You want to make sure that all these switches have low contact resistance. So I tested all these. Quite a few of them are around 30 milliohms. 45 milliohms is probably the highest, and that's acceptable. You don't want to have a situation where you select phono and then you have high contact resistance, and then what you're going to get is a dropout in one channel or the other. You want them all to be very, very good. So I tested them to make sure they were good, and they are. They tested out just fine. If they weren't good, I would be removing this switch block and taking it apart and cleaning it. The same with the microphone switch and potentiometer. Took this apart. I didn't take it apart. I took it out, cleaned it, and tested it. It's fine. I don't think this would get used much. That's probably the reason it oxidizes up, because nobody ever uses a switch. If you exercise it and use the switch, usually they hold up better. And then you have these 3 switches in the center. This one's the most important I wanted to point out. And this one here is the preamp out, main amp in. It either unites or separates the 2 connections here. And what I do is I just tack 2 wires on, and then I can test it. So this one here tests 65 milliohms. And this one here you really want to scrutinize, because this switch here can be the cause of a lot of problems when you, especially if you have a drop channel or a scratchy channel and weak channel, or one that goes quiet on you. High contact resistance here. So you want to make sure these switches are all good. These 2 are for phono stage, so you want to make sure they're good too. So what I did is I gave them a shot of neutral 401B and worked the switch a whole bunch of times, and then give it a shot of the red juice, right? And those will be good for many years to come. Done with this board. Let's see what else is there to talk about. I think that's it. And the next step will be cleaning the back with remove all the flux. This wire here, I don't know why they put that on here. It's a, if you follow this ground trace, it's all one connected, and it's all through here. This ground trace goes around. Yeah, I don't understand why they put this wire here to connect these. This is all ground, and there's no separation between them, so why would they put that there? And then they had it kind of hanging over the phono stage here. Are they using it as a shield? I don't know, but it's really not necessary. This whole board is kind of encased in a metal box when it's assembled into the amplifier, so I don't really understand the purpose behind that. Anyways, like I said, cleaning the back now, and then reinstall, because I'm finished. Yeah, I did forget to mention one thing. These 2 tantalum caps are bad. These are 1 microfarad, 25 volts each, and they are in the phono amplifier stage. They measure out about 6 or 8 microfarad, really high ESR, about 500 ohms, so they're garbage. And the other ones I pulled out, they tested fine, these other ones. So it's odd that you have the odd one that goes bad and the rest are perfect condition. Okay, update time. So this is the Protect board, and it's been serviced. I replaced a few caps, 5. These 2 caps here were 220 at 10 volts or something. They were back to back in series. So I removed both caps and replaced it with a 100 microfarad bipolar cap. And that takes care of that. And then I replaced a bunch of carbon comps here. I got rid of them. The relay tested about 200 or 300 milliohms, and clean the contacts. Now it's down to about 15 milliohms. So it's going to go back in. I can do that now. Clean the back, and then this board's finished, except for adjustment. And we'll put that back together. All right, bit of an update. Okay, I serviced these 2 boards, pulled them out, cleaned them, replaced the capacitors on these 2. Not much to talk about. I resoldered a bunch of stuff in the back that looked kind of suspect and really weak. These boards were wave soldered, and some of the joints are very sparse on solder, so they're probably pretty weak. So I just added some solder to strengthen them up, and just go through, make sure everything's good, put them back in after they're cleaned. I'm going to focus next on replacing these 4 caps. I got the new ones waiting, and it's just a matter of disconnecting wires, replacing them. Now I was looking at these 4 bleed resistors. There's a 5.6K resistor here and here, and I believe in the schematics it says that there's something like 57 volts across this capacitor. You do the math, that's about 600 milliwatts on each resistor, so together there's about 2.4 watts of heat just being wasted when this thing's turned on just by these bleed resistors. So I'm going to upsize these from 5.6K to about 10K, and just reduce the power consumption of just wasteful power consumption of these bleed resistors. It'll still bleed down these capacitors. It just won't be as fast as this, and I don't think it's necessary to have it bled down that quickly. So these capacitors I purchased are snap capacitors, which means they're meant for printed circuit board application. You get 5 holes and you put it on the board and solder it in place. But we don't have a circuit board here. The ones I'm replacing had solder lugs. So I cut off the dummy tab. We don't need that. That's gone. Okay. These two are negative. These two are positive. They're marked by the, I don't know if you can see that on the can, stamped positive there and negative there. So these two are connected, these two. And I checked that with an ohm meter. Yes, that's the way it is. Now, replacing solder lug. So I'm just going to add 14 gauge copper wire between the 2 pins, and I'm just going to bond these pins together. Make sure that if one connection fails, there's a backup, so we've got redundancy. So I'm just going to solder these. 14 gauge solid wire soaks up a lot of heat, so you got to make sure you get a lot of. There we go. Anybody know where you get cheap solder nowadays without getting a bank loan? Okay, so I got that, and I'll make up another one for this. And then once they're installed, see, I got my these two are prepped already. Once they're installed in the chassis, I'll take my 14 gauge wire and I'll run for the common ground. I'll run from these two to these two, and I'll probably run I'll just run one wire. 14 gauge is pretty heavy. We have about 2 inches between the 2 caps, so that's about that distance there. And then the wire will run. I'll wrap the wire around these two, and then I'll wrap the wire around these two, and then I'll be our start ground here in the center. Now I've seen other manufacturers like Onkyo, they'll use a copper plate for the ground connection between the 2 caps. I could do that too. I probably could get a copper plate, drill 4 holes in it, lay it on the cap, solder it on, and then I can drill holes in the plate for my wire connections. I might just do that. I'll see what kind of copper I have laying around here. Yeah, maybe we'll do that instead. We'll do a little different. Instead of having the wire, we'll do the copper plate. So I got the first 2 caps in. From the top, it just looks the same as it was before. On the bottom, I created a copper plate. I used this stuff here. This is it's fairly thick. It's probably 0.2 millimeter sheet. It's not, you know, overly, but it doesn't need to be super thick because it will carry a lot of current. Don't worry. Made a T-shaped patch to go between the 2 capacitors and the chassis ground. Got a screw with star washers on there to bite in. So that's grounded to the chassis, grounded to the capacitors. Just puncture a hole in it, wrap the wire in, and solder. So these grounds are all connected. Everything's done. So I just got to repeat on the other side, and I decided to do it this way to get rid of this thing. I think it's a little bit cleaner looking. I don't know. You guys might have a different opinion than me, but I think it's fine. I just need to get a little better on my tin bashing skills. Okay, I've been putting it off till now. I gotta face it though. It has to be done. I've been trying to avoid doing this board here because it's not that easy. We have this monster pot that's in the way that has to come out before I can access things behind it, and it's soldered to the board here. And yeah, this is not going to be easy. I think what I'm going to have to do is just remove the front plate and have this board swing out this way, and then I'll have access to both sides. Because I have to do all these switches need to be clean. I think I'll start by just removing the meters, and the meters look like they're on a separate plate that is screwed in. And I think, no, it's welded in. Never mind. That plate is welded in. Okay, so I'm going to have to maybe disconnect a few wires. Or, no, I'm just going to leave it attached. The plate doesn't need to be removed, it just needs to be backed off about 1.5 inches so I can get this out, and then I can put the plate back while I do my work. Okay, let me work on this. Alright, I'm going to see if I can remove this plate. I got everything removed except for 4 screws, 2 on this side, 2 on this side, and I should be able to finagle the board out and get it into position. And then I want to put the plate back on because it's a structural support. This thing's still heavy, very heavy. It's got the transformers in it and everything, so it's quite still a beast, and it's in weight. So let's see. Our last screw here. I'm just going to leave the meters attached. I'm going to leave the LED attached. I don't want to disconnect anything I don't have to. Okay. This should separate. There, that's what I wanted to see. Now, I need to flip this up. Put this back. Let's put a couple screws back in. Yeah, this will help me quite a bit. I think caused me a lot of stress at nights thinking about how I'm going to work on this, but now I think I was just overthinking it. Now it's just a matter of going ahead and doing it. Alright, I need a screw on this side. I'll put all 4 back in just to secure it. Yeah, that'll work. Meters can stay. Everything's rigid now. Alright. Okay, I'm going to service these switches. I typically remove these switches and clean them. Now the way I do it is I take the switch out of the board, and these are rotary wafer switches. And I'm going to try a new cleaner. I've never tried this stuff before. This is CRC. A lot of people rave about this stuff. QD electronic cleaner. And what does it say here? Doesn't really say it's for contacts. Prevent contact failure. What does it contain? Isohexane. I don't know if that's probably not very good for you. But it's flammable, poisonous, all that stuff, all the good stuff. But usually a test for when I try a new cleaner is just spray some on some paper. And let's get this out. So what I did is I just removed the switch, bent these 2 tangs out that's holding this wafer in. We're going to do one at a time so they don't get mixed up. So let's pull this shaft out. And then this should be removed like that. And you can see the black oxides on there, both sides. Now another thing with these wafer switches of this type, you got to be really scrutinize these solder connections here. They can crack, and they can cause a bad connection between the switch and the board. So let's try and get some of this. Now I see it all evaporated. There's no oil stain here, so this is 0 residue. That's what that's what I was doing there when I sprayed it. I was just checking. So let's see how this stuff works. That's actually removing some of the oxides. Now the thing with these switches is you want to return them to their original position. The thing with these switches is you want to return them to their original position before you reassemble again. So I'm just going to go through here and clean this. This is dry. But it is removing a lot of the oxides. So let's put this back to where it should be. This side here, you can clean this and this. This stuff evaporates really quick. Now this is tedious work, but in some cases if you have a bad switch it needs to be done. Okay, I'm going to leave that. I think we're done. And I like to follow up with a little dab of deoxit right at the contact points. Not very much. That's too much there. And just distribute it. Okay, this one's ready to go back in. And take a magnifying lens and look at these. If they're cracked, wouldn't be a bad idea to resolder them anyways, because these ones look pretty scarce on. Let's just do that quick. Doesn't hurt to resolder them. It doesn't hurt to resolder them just in case you know, the pin got stressed when you were pulling it out. Okay. Now this is ready to go back in. And it goes back in the same direction as the other one, so it goes back in like this. And we should have our slot aligned so that when we put our peg back in it, and close these up. Let's try this one. Actually, let's do there. Okay. Make sure the pins are all nice and straight so they go back into the PC board. And then we'll do this one next. Just going through and doing this next switch here. This is the stereo mono, reverse stereo, left right. That's the switch that handles that. And a lot of these joints here are cracked. I looked at them with the lens and you can see the cracks. Yeah, they're quite bad cracks too. So I'm going to go through and resolder these. So yeah, that's what I was talking about last time, is make sure that that's good. And you can't really see, once it's assembled, once the switch is assembled, there's no way to get to it from without removing the switch and taking it apart. Okay, I think I'm all done here now. I removed all these switches and disassembled and cleaned them. All the new capacitors, except for two here I missed. I'm going to have to replace those. I pulled off all the 2SA750 transistors and tested them, because they are on my naughty list, and they I just wanted to make sure they were okay, and they are. They're not exhibiting any problems with beta. They're all good, and everything else has been done. I just need to clean the back of the board now and put it all back together. I will solder on the potentiometer pot once I have everything back in the chassis and screwed down and bolted, and then I'll solder these connections. You don't want to solder them first and then put it all, assemble it, and then there'll be stress on these connections and you might end up snapping the board or busting a pad off. So last thing you do when everything's installed, solder it. And that'll be that. I'm not treating this pot. It's I think it's fine the way it was. I didn't when I was testing, I didn't have any issues with it, so there's really no need to dig into it. Should be lubricated for life. Just make sure the board's clean and the solder connections are good, and it can go back. The CRC electronic cleaner, I kind of like this stuff. I'm not keen on the smell. It gives off quite a strong smell to me. Isohexane is an isomer of hexane, and it's quite flammable. It's a very good solvent for removing grease or oil. Like it strips everything of grease and oil, and it's non-residue, so it leaves nothing behind. It actually works pretty good on the contacts of these wafer switches. When I was doing it, it kind of removes a lot of the oxidation, the loose oxidation that's on the silver. Doesn't remove all of it, but it does a good job of cleaning it and removing all dirt. So that's not bad. I like that. I picked up a can a while ago, and it's been sitting here and I haven't used it yet. So, but yeah, isohexane, you don't want to be breathing this stuff in or getting it on your skin. That's for one thing, for sure. So I'll finish with this, put it all back together, and then that concludes everything on this chassis done. Yeah, everything's done except for the power amplifiers, which I'll get to next. We've got some weird stuff going on with this power switch. I don't know what it is. It was loose. Actually, first off, these screws were missing, the mounting screws on the switch assembly, and this was all flopping around. But this is still loose in this. Somebody removed this switch and put it back in and didn't crimp it properly or something. This is one of those power switches that has the double pull, double throw portion of it that's used to control something else in the circuit. But if you look here, there's two jumpers, one here that's been cut, this one's been cut. I don't understand why they would cut those. The switch has two portions, the top and the bottom. They both work in unison. On the back side, somebody just tacked the power wires on. It's not even properly wrapped and terminated. And then there's more jumpers back here, and then they tack wires on. It was done pretty poorly. There's a solder burn here, iron burn here. So I'm going to clean this all up. I think this is just, if I heat this up, it'll probably fall off. Yeah. It's not wrapped. And the other one is just tacked on. I can see it. Yeah, it fell off. Not very good. So let me check the contact resistance on this. They do have two jumpers on this back side. You can't see. But I'm going to clean this all up. Somebody was just wrapping wire and blobbing solder on it. Okay. What I'll do is I'll clean up the back connections here. Doesn't look the greatest, and then I'll attach the wires to the front here, and maybe I'll add a suppression cap too while I'm at it, so it's easy to get to. I'll just throw a cap in here. Okay, give me a minute. The contact resistance of the power switch is very good. It's only like 0.4 or 4 milliohms. It's doing a really good job. Okay, so I just cleaned this up a bit, removed the wires from the back of the switch, and properly terminated him here on these lugs, and then added a surge suppressor cap, 10 nanofarad, and checked the contact resistance like you saw. It's good. I'm just going to leave this alone. I don't like the way the switch moves when you activate the switch. You can see how it bounces around there. That eventually can break wires off. This looks like the original switch though, because I see original factory solder joints here with the blue felt pen touch when they do their quality checks. You can see all the blue dabs on each joint. And the wires have not been removed. Somebody had this switch apart or out and did some work on it, and then they just put it back in. But it's a lot better now than what it was, and we'll leave it at that. Next up, I need to solder these connections back up here, all these ones. These all have to get resoldered. And you do that last after you tightened up all the board mounts on the front, all the switches, all the screws, and the knob nut on the knob shaft here. That's all tightened down. Everything's tight and secure. Then you do your solder last. If you do your solder first and then start tightening these nuts down, you can actually lift traces or crack traces or crack the joints or pull them off the board. That's what I'm trying to get at here, is you don't want to have any stress on these joints when you're done, and the only way to do that is to solder it last, and then it'd be stress free, and then that joint should last for a long time as long as things don't move, right? Alright, on to the power amplifiers. So my plan for this is not much. So let's see. I'm pretty sure it's got all the original silicon in it. RA-1412. 2SD. Somebody tried spray painting this? I think they did. Looks like somebody tried painting these in place, and the transistors got splattered. So I'll remove these transistors, test them, and repaste the goop on the thermal compound and put them back. As far as this goes, I'm not going to do much. I'm going to replace the 4 caps. I'm going to replace these few carbon comps, the 10 ohms here, and then there's a 10 ohm here, and then there's one under here. 330 ohms, I'll probably replace those. Board cleaning, it's not actually that bad. It's a little layer of dust. I might just clean that up with a cotton swab and some alcohol, just to dress it up, make it look better. Let's see here. There's not much to do to these. It was, it was working when I got it, and I was testing. It tests out fine. Just cleaning, disassembly cleaning, and new caps. Okay, I'm going to unsolder these 2 posts, and I think I can do that right now. Let's try this. Just because I don't want to break the leads off. The leads will break right here, right at the body of the device. So I'm just going to grab the post, and if I can get a squint underneath. Pull that out. Try this side. I'd rather take the time and desolder these 2, and then instead of breaking those wires and then crying about it after, I can just remove this, put that aside somewhere safe. Now, look at the back side. Looks pretty good. Some cracks on this transistor. Yeah, I'll give this a good clean, inspect, and then new caps, new resistors on those spots I mentioned. I'll take the transistors out and scrub the heatsink. Looks like somebody tried spray painting this heatsink. Yeah, all these screws are loose. Not a single one of them is tight. I'll just remove everything and clean it up. The compound is quite dry on this side. This side actually ain't too bad yet. It's let's see here. Oh yeah, well, it's dry enough. 50 years, it's time for a refresh. Oh yeah, so it's necessary. Alright, so I finished the power amplifiers. That went well. It took me pretty much all day. You watched the time lapse of that. I did one of them on time lapse, the other one I did without. I took some pictures. I don't know if you noticed, I took pictures in the middle of that, and these resistors have some corrosion coming out the ends. And I'll put a picture up on the screen so you can see it. But I don't know if you can see that on the end of this resistor. It measures fine. It's about 5% out tolerance. All of these resistors are about 5% to 8% out of tolerance, but they get replaced. So that's what I did. Elna caps are holding up good. These are, like I said in the last ROTEL video, these vintage Elna caps are probably the best you're going to get. There's really no better caps than these. They hold up the best, and these ones test out about 108 to 111 microfarad, about 30 milliohms ESR, and these are 100 microfarad. But what I did is I upsized them to 220s at 63 volts, 220s, because these are hanging on the power supply. I also added two capacitors here. These are 1 microfarad film caps, and they actually had spots for bypass caps, and I just populated it. So that should help as well with any noise that's on the power supplies, and that should take out any transients. Pretty much. Oh, I did. I replaced all these little aluminum plates and I put in some proper heat sinking, and you can see it there on the drivers. Now, if that's going to make a difference or not, who knows? But it should keep it a little cooler. Another thing you probably noticed, I was cleaning with lacquer thinner. Somebody spray painted these covers black, and they pretty much oversprayed everything. So I was cleaning up. You can see it's kind of green. That's the original anodized aluminum, and then somebody spray painted black on it. You see the black spray paint. So I did some cleaning around inside here and cleaned up all the overspray. There was overspray on the transistors, overspray on a few other things. So I cleaned that up, and it's all good. Everything went back together, just honky-dory. Everything's great. Okay, we're back together. I got the amplifiers in this morning, got it all soldered back in, and I think I'm ready to do a power up. So let's turn this on. I'm going to do it a controlled power up with a Variac for the first time, just to make sure that there is anything weird. So that's powered up. This is powered up. So let's turn this on. We should hear a relay click, and I'll watch the ammeter. Here's our relay click. So we did our safe power up. I always do a safe power up whenever I do new filter capacitors. You don't know if you have a faulty capacitor from the factory or something. It's a chance that you don't want to take. So looks like everything's working. The meters are lit. Okay, let's shut this off. Take it off the Variac, and then from now on I'll power it up straight from the mains. Just doing the bias adjustment here. Right channel, it's got 31 millivolts. It's slowly climbing up. Left channel is 29. So I'll just let this idle for a while, and I'll tweak it as it warms up. The idea is when you first turn it on, your bias adjustment is going to be out of whack, and then the amplifiers have to come alive and warm up, and then the bias adjustment the biasing will settle, and you want it to settle at 30 millivolts for each channel. And as it warms up, see now it's already at 32 and climbing. The target is, after the amplifier's been turned on for 10-15 minutes and it's warmed up, you want your targets to be 30 millivolts each, and right now we got 57 watts and staying kind of stable at 57 watts. We'll see how it is when I'm done with the adjustment. See, this one's already gone up. I'm going to turn it down a little bit more, and then so you're kind of chasing a moving target here. So just turn this one down a bit and then let it stabilize again. The reason why I want to stabilize is every time you make an adjustment, you're putting either less or more heat into the heatsink. And the big thermal mass of heatsink, it takes time for it to warm up and stabilize. Your transistors are your heaters, and your heatsink is your obviously it's a sink that dissipates all the heat away. See, this side here is already feeling warm. Shouldn't though, because they're both at the same. So maybe I got a problem on this side. I don't know. I'll just keep playing with this until I get it right. Some of this mask here for the switches is the glue has failed and it's peeling off. And whoever took this apart last time didn't put it together properly. You can see it's all messed up. So I'm just going to use some UV resin. I'm just going to put the smallest amount down. Just going to use a real small amount of UV resin. I get carried away here. Should be good. Now if I could just get this to lay flat. And just hit it with the UV light and cure it. Hopefully I got it. And that should keep that pin down for a while. One of the problems I had before I started on this was these function buttons. They had a crunchy feel to them. When you pushed one in, and then here, maybe I can demonstrate it if I can get it to work. No, it doesn't matter. But what happens is you press the button in, it's fine. But then when you press another button, this one pops out. And the inertia of the button coming out would pull, the button would come off the shaft a few millimeters, and then it would sit a few millimeters out. And then when you press the button again, it has a crunchy feel, like as the button seats to the bottom before the plunger goes in. One way to do that is tighten up the bond between the plunger shaft and the button. I just use a little piece of masking tape or painter's tape and just cut a very thin piece, just enough to, all you want to do is build up the thickness of that, and this is better than just gluing the button on, because you glue the button on and you'll never get it off again, or you'll destroy the button in the process. There. And it doesn't have that crunchy feel anymore when you're manipulating the buttons. It feels good. And they're on there tight, they won't fall off. So I also want to mention that if you're going to do the adjustment for the power meters, you have to remove this left side plate, and you can't remove the left side plate if the front plate is on. So you want to do that adjustment before you put your front plate on. Otherwise you're going to be disassembling everything to get at the potentiometers. So good thing I remembered. I'm going to take this side plate off right now and do that adjustment. And it's pretty simple. Yeah, you connect the sine wave to the amplifier, turn it up until you get 10 volts, I think it said. 10 watts, 8 ohms. 9 volts. 9 volts RMS, 10 watts. And then you adjust the meters to correspond to that, and then you're done. Okay, a little bit of a cock up here. What we're looking at is the output of the preamp on the right channel. Okay, I'm going to switch it over to the left. You can see we have quite a big difference in amplitude. I just wanted to confirm it's not the power amp, and it isn't. I noticed this when I was doing the power meter adjustments, that one channel was quite a bit lower than the other, and see the right channel is quite quiet. So that is a problem in the preamplifier. and I'll have to go through and figure out what's going on with that. So give me a minute. So this is what's coming out of the tape monitor. So this should eliminate everything before this pickoff point. So that's one channel. There's the other channel. They're both identical. So the problem is in the preamplifier. I'll just have to figure out where and what went wrong. Alright, let's have a look at what I've checked so far. This is the preamp circuit, not the whole thing, I can't fit it on the screen. But here's our bass and treble attenuators, and here's a little amplifier here. So first thing I did is I checked for signal on the bass of Q501 and 502, and this is where the signal comes in off the volume control, and amplitude is equal on both of these. Alright. So then I switched strategy and I decided to check this output capacitor here, 539, 540. It's a 4.7 capacitor before the signal heads out. And I checked here, and the signal is equal. So that rules everything out in this area is fine. And then I went straight to the output of the preamplifier on pin 3 and 4 and tested, and we have our discrepancy on pin 3 and 4. So either there's something wrong with one of these two amplifiers, or something with the switching. Actually, the volume control's right here. I thought this was the volume control. This is the balance control. I don't expect there's anything wrong with the volume control though. I didn't touch it. I didn't take it apart. Could be something with the switches I did. Or what is this? This is the minus 20 dB, 10 dB. I'm going to check this switch here. Make sure it's working. We might just have 10 dB of attenuation on one channel only. Yeah. Okay. So I'm going to go after, with the scope, I'm going to go after, let's see here. Go in the base of Q511 and what is this transistor? Is it marked? It's not marked. This would be 512, but it's not marked. And then we have 13 and 14. So I'm going to check the base of these input of these two transistors, 11 and 12. And then I'll see if we have a discrepancy. I think I might have screwed up when I took the switch apart. Maybe I screwed up this attenuator switch. Maybe that's what's going on here. Maybe I got attenuation one channel only. Yeah. We're zeroing in though. We're getting close. Okay, so I checked the signal on this attenuator switch, and it's equal for both channels. So that's not the problem. And then I checked Q511, 512 on the base and emitter, and the signals are equal on these two transistors. But when I come to pin 3 and 4, here I got a discrepancy. So I'm beginning to believe there's not even a problem with this board. It might be something loading down one channel or the other. I'm going to check these two output transistors. This is 13 and 14, and the signal goes in the base, comes out on the emitter. So I'm going to put you up in the scope, and then we'll do this. I'll show you. I'll turn this thing on. Alright. So here's the base of 511. Oops. Here's the base of 512. You see they're both equal. Okay, let's go up. Let's go to the base of 513 and 14. This transistor here. We're going to get a good connection on it. That's really low. What about this one? That's really low too. What? I can't see very good here. Oh, I lost my ground. That's the reason why. Okay, let me connect my ground back up. No, my ground is connected. So I had the muting switch clicked. Let's try this again. Okay, the bass. Here's the bass. Let's turn up the volume. This is 13 or 14, I'm not sure. Here's the other channel. And They look equal to me. Now let's try the emitter, the outputs. There's one transistor, here's the other. And then it goes through a 1.5 microfarad cap to the output. This is pin 3, pin 4. So these two here are outputs, pin 3 and pin 4. And we have missing signal. Or hang on, do we? Maybe I got this assembled wrong. Yeah, something's wrong right here. Maybe I assembled it wrong. Let me check my work. Okay, I'm going to check for loading on this one line, the right channel. If we have something that's shunting that channel down, I'm going to connect my ohm meter between ground. And let's try the left channel first. Let's see what our measurement is. So we got about 150, between 150 and 200K. Let's try the other channel. We've got mega ohms. Why do we got a big difference there? That doesn't make sense. I wonder if we have a voltage on there. Let me check. I'm going to connect ground. You know, because if I install a cap backwards, that'll affect one channel or the other. So let's turn this to voltage. Let's turn this on. Let's connect this up to left channel. Turn it on. Pretty much 0. Let's check the other channel. Pretty much 0. That's interesting. This is the only place where I see a discrepancy on the voltage or the signal. And I did not remove any of these wires here. This is all remain connected. So what's going on here? These two go up to the output connector on the other board. Let me take that cover off and have a look at it. So just as a sanity check, I'm feeding a signal directly into the main amplifier, and if I put it on separate, the meters jump up and they read equal. I can manipulate the volume, and yeah, everything's good with the power amplifier. It's coming up to the power amplifier where I got a problem, so let me keep digging. Okay, I think I found the problem. I was searching on the wrong line. This blue wire here goes out to the output of the preamp out, and it goes to the switch to the main amplifier. This isn't the problem. The problem is this purple wire, which is tapped off of the output through a 3.3K resistor, I believe. Now this purple wire goes back up to the input board for some odd reason. I don't know why. And it's connected up here. But if I look, see, there's the right channel of the blue wire. Here's the left channel, and we got nothing there. And then if I go to the purple wire and check, we got high resistance on this line. This is the left channel. Got mega ohm there. If I go to the right channel, I got a dead short, 2.4 ohms. So whatever work I did with regards to this purple wire up here is my problem. I'll have to go and check it out. Let's go have a look. Yeah, that purple wire comes up here and goes to these 3 posts. And I did have these 3 posts removed, so I possibly might have a solder bridge on one of them. But I'm still kind of, why do they have this signal coming back up here? This is the input switch. This is our microphone switch and volume control. And this is our microphone input. I don't know what purpose this serves up here. So I have to remove this and I'll have to pull this board up and inspect my solder joints. I have a feeling I just maybe got a bridge here. Alright, got the board loose, ready to pull it out. Let's see what is going on here. What am I hooked on? Can't get it back far enough. It's hooked on something. Might have to release. I'm going to have to release these screws here and just slightly move this forward. Or maybe I could force it. I don't know. I don't want to break anything. You flip it up. There we go. So these are our 3 connections. Oh, look, looky, looky, looky. Can you see that? Can you see a solder bridge there? That is solder bridge, yes. My screw up. I might have to heat that joint. Hang on. Let's get an iron. There we go. It's gone now. Wow, that wasted an hour of my time. But we fixed it. Okay, back together for the last time. Now, I was thinking about this. Why do they have that purple wire running from the preamp board to the microphone? And apparently what that is your microphone output. And that allows you to mix. So you can have your music going with your regular volume control, and then you can blend in your microphone and sing along to your favorite tune. But yeah, I don't know. That was odd. But you know, it went through a 3.3K resistor, and then it was shunted to ground through my solder bridge. That's why I had a low channel. But it's gone now, and it's fixed. So we're going to go on, move on to testing. Alright, wired in, do power test. Let's get things powered up here. Turn that on. There's a relay click, there it is. We have our power, and we're on the scope. So let's turn this thing up. It's clipping. Okay. We're going to have to... the stepped attenuator doesn't give me much fine control over full clipping and not. So I'm going to have to put this somewhere here and then do a fine adjustment on my signal generator. But first, let's increase that so we can see that better. Slowly turn it up. Ooh, this thing is, it's got long legs. Okay, there's clipping there on the bottom trace, the right channel. Take it down a bit and we'll leave it there for now, and we have 30.9 volts RMS on the output. So let's see, we have a good overlay. The right channel is a little louder than the left. I'm pretty sure my balance control is centered. Okay, well, let's start our test. And we are drawing, if you can see that, 395 watts going in. we have some watts coming out. I'm going to turn the fan on, and we are going to let this cook for 10 minutes. Okay, I don't know if you noticed something, but I extended the time on the test to 15 minutes, only because this wasn't even heating up. This is barely warm here. This thing didn't even break a sweat. So after 10 minutes I figured, I'll just extend it for another 5 minutes. That fan you heard was cooling off my load, not the amplifiers. The amplifiers are just sitting here, barely warm. I bet you they're about 40 degrees Celsius. That's the thing about quasi-complementary amplifiers, is they're highly efficient, or they're more efficient, I should say, than the regular amplifiers that use complementary pairs. Let's see what this says. 43 degrees. This side's a little hotter, 45. This amplifier can go all day long at full power and not even break a sweat. Now, let's turn it down. Now, the reason I do a 10-minute power test like this is some amplifiers fail miserably at this. You put it on full power, and after 6 or 7 minutes, the heat sink's already over 65 degrees, 70 degrees Celsius. In my opinion, those amplifiers aren't suitable for running 4 ohm loads. Even at 8 ohms, they can't keep up. But at 4 ohm load, it'd probably just kill it. This thing could probably be good amplifier for 4 ohm loads, and it's runs great. What more could you want? You know, this thing is built like a tank, and it's ready to do the business. Alright, so let's get rid of this. Let's do some square wave tests and then wrap this up. Okay, we got a square wave, 1000 hertz. We're putting out about 1 watt, and our meters are reading probably about 3 watts. What do we got in the output? 2.4 volts RMS on this, so it's a low amount. It's nothing crazy. So that's 1 kilohertz. Let's have a look. Our bass control and treble controls are out right now, so these should have no effect, these switches. Let's switch it to 200 hertz. A little bit of a change there. It shouldn't be, ideally it would be nothing, but there's a little bit of a change there. Let's turn this down. Bass cut, bass boost. Okay, 400 hertz. A little bit more of a change. I think it might be just little drifts in the resistors that they're using in there, because it's all attenuated switches. Bass cut, bass boost, 400 hertz. High filter, or high turnover. This is 2.5 kilohertz. Let's try it without first. No changes. Very little change. 2.5. Treble cut. Treble boost. It's quite a large effect. 5 kilohertz. Treble cut. Treble boost. Now you see, the problem with these switched attenuators for the treble and bass is you have either that or that. You don't have any in between, because you're just switching between 2 fixed resistors, and you can't fine-tune that any more than what it is. It's just either one step or the other. Personally, I don't ever use tone controls. I always keep them cut out or on flat. Alright, 15 hertz filter, very slight amount. 30 hertz filter. 8 kilohertz high filter. That really looks odd. And then that's the 12 kilohertz high filter. Stereo reverse. This is the muting switch. This is the loudness. Oh, this is the loudness switch. Okay, loudness 3 dB, 10 dB. And then we have 6 dB, 20 dB, which is a higher step. So you got 2 different loudness levels, one low and one high. And this is your muting, -10, -20, Everything's working perfectly. Tape monitor switch. That's it. Balance control. And of course volume. Alright, let's go up in frequency. See how it looks. Let's go here. 2, 3, 4, 5. That's pretty good square wave for 5 kilohertz. 6, 7, 8, 9, 10. I'm liking this. 11, 12, 13, 14, 15, 16, 17, 20, 21. Now we're starting to see the effect of the rise and fall times. 21 kilohertz. Let's go up. Start to lose our square wave right around here. This is 43 kilohertz square wave. It's pretty good. This is one of the better ones I've seen. Yes. Very desirable amplifier. Very nice. Very nice. Alright, here's a look at the parts that went into it. 4 new filter caps. These are Nippon Chemcon. They're down in value. Between 14 and 17,000. These are supposed to be 22,000. I did some upgrades to the heat sinks on the 2 power amplifier driver 4 transistors. I replaced the heat sinks and upgraded them, get better cooling. And when I did the power test, I was my finger on them, and they really don't get that hot. So it probably wasn't necessary, but I did it anyway. Why not? Got rid of a bunch of carbon comp resistors. These, for the most part, tested fine, but I don't trust them. I remove them as on site and get rid of them because these ones had a little bit of corrosion coming out the axial ends, and I just don't trust them. They drift with temperature, they drift with age, so yeah, get them out. These orange drop caps, these are low noise, Nippon Chemcon, and these are all the same value, 10 microfarad at 25 volts. These all test good. They all come back at about 11 microfarad. They have a good ESR. They're holding up for 50-year-old caps. They're still good. Same with the Elnas. All the Elnas I took out, the gray Elnas, they are testing fine. I didn't find any that failed. Now you could still run with all these caps, no problem. I wouldn't have any problems with that. So replacing these at this point really didn't provide any benefit to the operation. It's a couple of black ones there. But I did find 2 failed tantalum caps, so I replaced them all. 2 failed ones were in the Phono stage, and they had really high ESR, so we got them all out. And then I redid the star ground arrangements for both power amplifiers. I got rid of that, and they have these cheap plastic wire nuts on. I don't know if this is factory or not, but it came in on the power cord. There's the 2 wires twisted together. It wasn't even soldered, and then they put this wire nut on there, and then it looks like they tried gluing it on. I got rid of that, soldered it, put heat shrink on it, insulated it properly, and that's fixed. So this is all the parts that went in. It's quite a bit of work, and I think this will last another 50 years for sure. Well, there it is. It's done. It's quite an impressive machine. I'm really impressed by this amplifier. If this will tick a lot of your boxes, to tell you the truth. It's got the power, it's got the looks, it's got the features, it's got the build quality, it's got the performance. It's all the complete package. I don't know what more you could want from an amplifier than one of these. The only thing I don't like about it is size. It is fairly large and it's heavy, and power consumption is not the greatest. So when you're sitting idle, you're drawing 50 watts. So just everyday listening, you probably want something that's more efficient. But this thing is built to do the business, and it's impressive. Can't say enough good things about it. Bad thing is I have to give it up now back to the owner. So we will test it for a few weeks, and I'll enjoy doing that for sure, and then pass it back to the owner. Anyways, phone's ringing, so I gotta get going. So thanks for watching. Take care, and we'll see you on the next one.